This Zoom session is being brought to you by the Fractal Inverse Bullseye S Swirl. For today, we go to section 4.4. Definitely a triangle measuring section because we'll be measuring the areas of triangles. And there are various ways, various types of triangles that measure. There's base and height, there's side angle side, and there's side side side. Also, there's in the extra credits, there's a section which I'll go, which includes angle side angle areas, but that's really all right. Area of a triangle. We start with a triangle whose base B and whose height H is given. The height is the length of a perpendicular altitude to the base. Now you can write that triangle inside the circumscribed rectangle, and the area of the rectangle is H times B, and the triangle, well, it's half the area of the rectangle because this triangle has the same area as this, and this triangle has the same area as that. So half of that. So if we use the letter K for area, I suspect it's from German because we can't use capital A because we're already using that for a side A. All right, so if A is the area of the triangle and it's half the area of this H by B rectangle, so K, the area of the triangle, is 1/2 B times H. Simple enough. Now we're going to do a side angle side triangle. Side A, angle gamma, side B. Now, all right, we drop a perpendicular H, and H over A equals sine of gamma. So H equals A sine gamma. So plugging that into this, K equals 1/2 BH. You plug in H, half A sine gamma for H, and then you get K equals 1/2 AB sine gamma. Now, if you switch around A to B to C to A and gamma to alpha to beta, just changing the labels, then you also get the equation K equals 1/2 BC sine alpha and K is 1/2 CA sine beta. Standard stuff. Okay, then. And I dare say that because of these three, all these three things are equal to K, you can deduce the law of sines from it. Okay, so this gives you the side triangles. Now for a side triangle, given sides A, B, and C, then K is this expression where S is A plus B plus C over 2, half the perimeter, therefore called the semi-perimeter. And K equals the square root of the quantity S times S minus A times S minus B times S minus C. This is a nicely symmetrical formula. If you switch around A, B, and C, you get the same formula. So we only need this one formula for side problems. All right, we're going to go through a couple of pages of derivation. So here we go. We start with the law of cosines. C squared equals A squared plus B squared minus 2AB cos gamma. Now, there's a formula, the half angle formula, which says that the square of cosine gamma over 2 is 1 plus cos gamma divided by 2. So therefore, and using the arc cosine law, we can derive cos gamma. And so we get cos squared gamma over 2 is half of 1 plus cos gamma. And by the arc cosine law, this cosine gamma is A squared plus B squared minus C squared over 2AB. That plus 1 all over 2 is cos squared gamma over 2. So cos squared gamma over 2 is, after a little bit of algebra, it's A squared plus 2AB plus B squared minus C squared, all divided by 4AB. And then this, A squared plus 2AB plus B squared, is A plus B quantity squared. That minus C squared over 4AB is still cos squared gamma over 2. We have a difference of squares, which equals a difference times a sum. So cos squared gamma over 2 is A plus B minus C times A plus B plus C all over 4AB. And then if you use the definition of S, the semi-perimeter of half the sum, and this is easy enough to verify, is equal to S minus C times S all over AB. All right, now we use a similar formula for sine squared gamma over 2. That's 1 minus cos gamma over 2. That's just the half angle formula again. And again, plugging in cos gamma into as A squared plus B squared minus C squared over 2AB. The sine squared gamma over 2 is 1 minus the quantity A squared plus B squared minus C squared over 2AB all over 2. then we can, by a set of steps similar to what we have here, we get that this equals, after some work, rather like here, S minus A times S minus B over AB. Now here's the thing. K, the area of the triangle, is a half AB sine gamma. Now we can write sine gamma is twice sine gamma over 2. And then we can use the angle doubling formula. Sine of twice gamma over 2 is twice sine gamma over 2 cos gamma over 2. But look, lo and behold, we have them right here. It's cos squared and sine squared gamma over 2. Okay, so a little bit of work. K equals AB sine gamma over 2 cosine gamma over 2. And sine gamma over 2 is, from here, is S minus A times S minus B over AB. And cos gamma over 2 is root of S minus E times S over AB. And then we could combine the roots. Root AB times root AB is just AB. AB root S times S minus A times S minus B times S minus C over AB. AB cancels, and we're left with K, the area of the triangle, is root of the quantity S times S minus A times S minus B times S minus C. A bit of a pull. That's about a page and a half of derivations, and you had to first find square of half an angle for reasons that weren't obvious until we look here. But here we go. It's called Hero's formula because it's so heroic. It's also called Heron's formula after Heron of Alexandria, who discovered this rule a couple thousand years ago. Math's like that. You discover something and people will remember it and your name thousands of years later. All right, so here's the area of a side triangle. So let's do some examples. All right, here's a triangle, sides A, B, and C, angles alpha, beta, and gamma. A equals 3, B equals 4, and gamma, the angle in between is 40 degrees. What's K? All right, it's a half AB sine gamma, so 1/2 times 3 times 4 times sine 40. Push a few buttons on a calculator and get the K as approximately 3.856. I recommend at least 3 decimal points. If A is 3, C is 2, and beta is 110, well, again, beta is between A and C, so we can use the formula. 1/2 times A, which is 3, times C, which is 2, sine gamma, which is 110. Here we go, 1/2 times 3 times 2, sine 110. And the calculator informs us that this is 2.819 to 3 decimals. Now, a side problem. A is 5, B is 8, C is 9. All right, that's a side problem. Oh, there you are. And so we first calculate the semi-perimeter. Half of 5 plus 8 plus 9, that's 11. So K equals root of S times S minus A times S minus B times S minus C. So it's root of S, which is 11, times S minus A, 11 minus 5, times S minus B, 11 minus 8, times S minus C, 11 minus 9. And okay, so this is root of 396. You can pull out a 36 factor, root of 36 times 11. That's 6 root 11. So K is 6 root 11, which is about 19.8997. The book gives this thing about something called the Flatiron Building, some triangular building, which in New York City. I don't know why, I'd never heard of it before, but apparently they thought of it of interest. And the lengths of its sides are 190 feet by 87 feet by 173 feet. What is its area? All right, well, first down the semi-perimeter. 73 plus 87 plus 190 all over 2, which comes up to 225. So K equals root of S, S minus A, S minus B, S minus C. That's root of 225 feet times 225 minus 173 feet times 225 minus 87 feet times 225 minus 190 feet. So that the square root of 5751100 fourth power of feet. I'm amazed that Heron even came up with his formula because it seems to be talking about fourth powers of lengths, which might appeal to a science fiction writer as the hypervolume of a tesseract, but I don't. I think the Greeks were too concrete minded to ever even consider 4-dimensional objects. Nonetheless, here's a square root of a fourth power, and that's a second power, square feet, as it should be. Root 5751100 square feet, approximately 7517.4 square feet. All right.